Hello Year 12 and welcome to our first video here for our 18th topic, geometry. Now, there is an awful lot potentially in this topic, but I do rely on you having already learned an awful lot of geometry and understanding these things. The real focus of this geometry topic is not learning the geometry itself, but the elements of logic and formal proof. Okay, so this is very much not about finding the answer, but about producing a sort of compelling or convincing argument that this is the right answer. Okay, showing someone else why this is the correct answer. That's the focus for this topic. Now, you'll see here all of this terminology I've put at the start of the notes. Hopefully, you are familiar with all of those words. If you're not quite sure, couple of them, like maybe median and altitude, you might think you know what they mean. Maybe not in terms of geometry. There's a couple of them we pick up as we go along, but mostly you should already be familiar with those, which is recognition that you've done a lot of geometry in the past, that you've learned lots of things, that you know what, a hexagon is and a rhombus and a kite, a quadrilateral, an acute, an obtuse, or a reflex angle, and so on. Right? We're not going to go over all of that again in this topic. We're going to begin with points, lines, parallels, and angles. Now you will see I have written all these dot points throughout these notes. So many of them. You can rely on any of those statements that are there, not because I wrote them, but because I've copied them. You can rely on those statements. You don't have to prove them. Okay, you can use all of those statements when you are providing an answer. Right? You don't have to go all the way back to the absolute fundamentals of geometry every time you're solving a problem. You can rely on these ones here. Okay, it's understood that you can speak to those. Just some things that might want reminding. Complementary angles aren't ones that tell you you're looking good today. Complementary angles with an E there after the L. Complementary angles add up to 90 degrees. Supplementary angles add up to, I put them in the wrong place. Supplementary angles add up to 180 degrees. So, for example, the interior angles of a triangle are supplementary. Adjacent angles share an arm. Vertically opposite angles, corresponding angles. Now, looking here, let me just grab my little draw thing. Okay, now, this angle here and this angle here, they would be corresponding angles. Right, they're corresponding because they are both to the left of this transversal, this line running across our pair of lines that may be a parallel, maybe not. We have a transversal, cuts both of the lines. Now my angles here are both to the left and they are both above that pair of lines. They could both be on the right, they could both be below, something like that. But in this setting here, in this arrangement here, they are corresponding angles. Now, if I had angles like this and this, they're vertically opposite angles. Okay, that's what we call vertically opposite angles. Let's have a look at, we can have alternate angles. Right, this one here and this one here. They're alternate angles, right? They're both sort of inside my pair of lines, but on opposite sides of the transversal. And the last one are co-interior, and that's like this one and this one. Co-interior. Now, they're not equal. Co-interior angles are supplementary. They add up to 180 degrees. They're a little different. The other ones are all equal. Now, I've got a question here. Calculate the value of theta. There is a trick to this question, and the trick is that you need to do a construction. Right? Sometimes you need to add something, draw something extra on your diagram that will make it a bit easier to solve. Now, if I construct a line from F over here, I'm going to call this G. I'm going to construct a line FG that is parallel to AB. So I need to write that down. I need to say what I'm doing as I go along. Oh, that's the wrong pen. Okay. So I'm going to write down here. Right. You can't really write too much. You can certainly write too little. Construct FG, and this is my symbol for parallel to, let's call it AB. Okay, so we've done that. Now, with that parallel line there, now I could say that I have alternate angles. So MFG equals AMF. Okay, so we write that down. That's going to be my second line of working here. And I will say that GFM, so I'll use this little angle symbol, GFM is equal to AMF. Oops, got my little angle symbol. AMF, you need that angle symbol or it might look like a triangle. And I put in brackets and explain why that is the case, because they are, I'm going to say, the alternate angles on parallel lines are equal. Okay, that's one of those statements that's in the notes. Alternate angles on parallel lines are equal. Okay, and now I might say my three little dots here, therefore GFM angle GFM equals 110 degrees. And I quite like, once I've worked something out, to write it on my diagram. Okay, it could be neater. You can see why it's a good idea to work in pencil too. Right, so GFM 110 degrees. Now I'm going to do something very similar. I don't have to do another construction, but I'm going to do something very similar with the angle GFN. So I'm going to say that the angle GFN is equal to the angle CNF. And again, I have to write the full explanation. Alternate angles on parallel lines are equal. Rightio. And again, I'm going to say, therefore, angle GFN equals this time 120 degrees. Rightio. So we've used these parallel line properties, we've used alternate angles twice now, and we have found two angles there. Two angles that are certainly adjacent to theta. And together those three angles will make a revolution. So now I'm going to say, I'm just going to scroll up a little. Oops, not quite that much because I need a little reference point there. I'm going to say that BMF, angle BMF plus the angle, not BMF, I don't care for that, hang on. Okay, sorry for the confusion there. I'm going to say that the angle MFG, right, I want the angles at F there. So, the angle MFG plus the angle GFN plus the angle NFM, which is theta, equal 360 degrees. And why? Because adjacent angles, actually, let's just check what we say here, is there is a statement here that says that adjacent angles in a revolution add to 360 degrees. Right, there's my statement. That's what I'm going to write. Adjacent angles in a revolution add to 360 degrees. In a revolution. (360 degrees). Okay, now I can put in a sort of another therefore statement. I can find my cursor. Okay, therefore 110 degrees plus 120 degrees plus theta equals 360 degrees. Therefore, theta equals, right now we've got 230 away from there, leaves me with 130 degrees. Right, yeah. You can see that there is a lot of explanation there, and you think, well, I could have worked that out without writing all of that stuff down, but, right, can I stress, that's not what this topic is entirely about. That what we're really learning to do here is to come up with a line of reasoning and logic that is entirely unambiguous, that is free from any doubt or suspicion, that we have a solid proof there, that we can read that and be very sure that that's the correct answer. Okay, rightio. Well, that's going to be it for 7a. There is a lot to take in and a lot to practice, and you'll really need to check in with me to make sure that your work is not too long, like is not taking up too much space, but more likely to be the problem is that it's too brief and that it's missing explanations. And that's really what you're being marked on here as well, is that you provide sufficient justification or explanation for your work. Rightio, it's getting away from us now. I'll see you in class. If you've got any questions, make sure to catch me.